Hello, welcome to Pre-Cal Section 1.6 Homework Solutions. So I was able to get the first 7 of them on the board here, so let's get to it. Okay, so this is going to be the same as negative 343, number 1, to the 1/3 divided by 512 to the 1/3. So you can rewrite it as the numerator raised to the power over the denominator raised to the power. And we're just going to go ahead and use the calculator for this. So negative 343 raised to the, so the caret symbol, 1/3, 1 divided by 3 power. So that is negative 7. And then 512 raised to the 1/3 power is 8. All right, so that's just negative 7/8. All right, number 2. So I would like you to show this intermediate step on your homework and on a test. All right, 125 over 64 to the negative 2/3. So let's flip the inside. I'd have 64 over 125, and we can raise this now to the positive 2/3 power. All right, so 60, that's the same as 64 to the 2/3 divided by 125 to the 2/3. So I'm just showing that for illustrative purposes, but 64 raised to the 2/3 power. So it's the cube root of 64, which is 4, and then 4 squared, and that's going to be 16. The cube root of 125, so again, the way you would write that out is 125. The cube, the denominator goes in the crook of the radical, and then the 125 is squared. So the cube root of 125 is 5, and then 5 squared is 25. So that is 16 over 25. So we can try, if you want to, let's see, if we do the left parenthesis, 64 divided by 125, right parenthesis, and then raise that to the 2/3 power, it'll give you the decimal equivalent, 0.64 of 16 over 25. But what I'm looking for is the fractional equivalent, which you should be able to go into mode and change that to fraction if you want to check it that way. But I want to see this kind of work on your paper. All right, 8 over 27 to the negative 4/3. Let's rewrite that as 27 over 8. To the positive 4/3 power, and then 27. The cube root of 27 is 3. 3 times 3 times 3 is 27. 3 then to the 4th power, and of course you can put this in your calculator if you want, but 3 to the 4th power is 81. So the numerator is going to be 81. The cube root of 8 is 2. 2 to the 4th is 16. So if you're not able to do that in your head, you can just use your calculator, but it's good to be able to think through that. All right, number 4, 1 over 64. I can make this 64 over 1, which is just 64, right? And then to the positive 2/3 power. Okay, so the cube root of 64 is 4, and then 4 squared is 16. So the next one we're gonna flip the inside, so that's 64 over 25. So these are made kind of hoping that you have memorized the squares and the cubes of these numbers. They're pretty common numbers. So I changed the negative to a positive. All right, so the square root of 64 is 8. Now 8 cubed, that one, there's a good chance you don't know that. So we'll go ahead and raise 64 to the 3/2 power, and that's 512. All right, the square root of 25, see 2 goes in the crook of the radical. Square root of 25 is 5, and then 5 cubed is 125. So again, you can use your calculator on that if you need to. Okay, so number 6, I'm going to rewrite this all to the 1/2 power, 18s to the 6th, t to the 8th, u to the 11th, all raised to the 1/2 power. And then what do? We take each individual component and raise it to the 1/2 power. So 18 to the 1/2, well, that's not a whole number, so I'm just going to write it as 18 to the 1/2. You can write it as the square root of 18 also. S to the 6 to the 1/2, 6 times 1/2 is 3. So that's going to be s cubed. T to the 8th to the 1/2, 8 times 1/2 is 4, so you'd have t to the 4th. And then u to the 11th to the 1/2 would be u to the 11 times 1/2, 11 halves, or 11 over 2. And it's okay to have fractional exponents as long as they're not negative. In my class, some teachers would make you do this u to the 5th times the square root of u. I'm not going to make you do that. Because again, in calculus, we like fractional exponents. Okay, so number 7. What I want to do is raise all this to the 1/2 power, but I'm going to try to simplify it inside first. So 36 divided by 4 is 9. Then x to the 7th over x to the 3rd, 7 minus 3 is 4. Right, so I'm going to go ahead and write it up here. Let's have 9x to the 4th. Y to the 4th over y to the 5th. The y on bottom wins, so that's just going to be y. All right, so 5 minus 4 is 1, but we're leaving the exponent positive. And then z to the 5th, just over nothing, is just going to be z to the 5th on top. So I've simplified it. And I'm going to raise all this to the 1/2 power. So 9 to the 1/2 is the same as the square root of 9, which is 3. X to the 4th to the 1/2, 4 times 1/2 is 2, so that's going to be x squared. Z to the 5th to the 1/2, that's going to be z to the 5/2. And then on the bottom, we've got to raise that y to the 1/2 power also. So y to the 1/2. All right, you don't have to, I didn't ask you to rationalize that or anything like that yet. So if you, a problem like this, if I'm not asking you to rationalize, you can just leave that. You could also write that as the square root of y. All right. Got about half of them done. All right, let's be fast forwarded through that. Okay, 8. So we want to simplify the square root of 100 x to the 9th y squared z to the 6th over 4x to the 6th y cubed. Okay, so let's simplify what we can. We're going to still have a bottom term. And then all raise all of that to the 1/2 power. So 100 over 4 is 25. X to the 9th over x to the 6th. 9 minus 6 would leave x cubed on top. Y squared over y cubed. 3 minus 2 leaves a y to the 1st power, or just a y on bottom. And then we have z to the 6th on top. I've got to, don't forget, you simplified it, but now we raise it to the 1/2 power. 25 to the 1/2 is 5. That's the square root of 25. X cubed to the 1/2, 3 times a half is 3/2, so we have x to the 3/2. Z to the 6 to the 1/2 would be 6 times a half is 3, so we have z cubed. And then y to the 1/2. All right, it's easy to simplify the inside, but then forget to raise it all to the 1/2 power. So make sure you don't skip that step. Number 9, okay, this that one's a little hard to read, what's in the crook of the radical. Sorry about that. But it's the 4th root of 625 x to the 4th y to the -8th z to the 9th. So what I'm going to do is rewrite all of that, 625 x to the 4th y to the -8. I'll move that negative exponent term down to the bottom at the end. Z to the 9th. And we've got to raise all that to the 1/4 power. Okay, so on the top of my head, I don't know what 625 to the 1/4 power is, but I think it's probably 5. So 625 raised to the 1/4 power is 5. 5 times 5 times 5 times 5 will give you 625, so we have 5. X to the 4th to the 1/4. 4 times the 4th is 1, so that just leaves x. Y to the -8. -8 times the 4th is -2. I'll fix that in a minute. And then z to the 9th to the 1/4 would be z to the 9/4. So we're almost there. I want you to move that y to the -2 to the bottom. So you'd have 5x z to the 9/4 over y squared. Number 10. Okay, so we've got the cube root of 135 x to the 7th y to the 6th z to the -3. So the cube root is the same as the 1/3 power. So we're going to raise all of this to the 1/3 power. Okay, so 135, the cube root of 135 is not a whole number. Okay, you can try it in your calculator. But raise it to the 1/3 power, and it's a decimal. Okay, so we're just going to write this as 135 to the 1/3. X to the 7th to the 1/3. 7 times the 3rd would be x to the 7/3. Y to the 6th to the 3rd. 6 times the 3rd would be 2, so y squared. And then z to the -3 times the 3rd would be -1. So we're going to take that z and put it on bottom. So that's 135 to the 1/3. X to the 7/3. Y squared. And then all that, we're moving that z to the -1 to the bottom, so it's positive. All of that over z. Okay. So you may want to fast forward through all this. It's got to erase. Okay, let's rationalize the next 5. So number 11, we've got 6 over 5 minus the square root of 19. So we're going to multiply this by a clever version of 1, the conjugate. is 5 plus the square root of 19. Remember, just change the sign. Over 5 plus the square root of 19. So that's just a fancy version of 1. And multiplying the top, I would have 6 times 5 plus the square root of 19. And we're going to FOIL the bottom. So first is 5 times 5, that's 25. Then we would have 5 times negative 19. For this first one, I'll go ahead and write that. So actually, it's FOIL out. It doesn't matter the order, outside or inside, but 5 times the square root of 19. So that'd be plus 5 times the square root of 19. Minus 5 times the square root of 19. You should have done this a lot in Algebra 2. And then negative root 19 times root 19 would be just minus 19. So those middle terms go away. And you would have, I'm going to go ahead and multiply this out. 6 times 5 is 30. Plus 6 times the square root of 19. Because sometimes what's in the denominator will divide evenly into these numbers. So 25 minus 19 is 6. And so you can divide 6 into the 30 and 6 into the 6. So that'll simplify. 6 into 30 is 5. 6 into 6 is 1. So you just have 5 plus the square root of 19. So if you got to here, you'd get most of the credit on a test, but you won't get full credit unless you simplify it all the way down with this last step. All right, number 12. We've got 16 over the square root of 37 minus 6. So we want to rationalize that. Square root of 37. That's not 37. Plus 6 over the square root of 37 plus 6. So just change the sign. So we'd have 16 times the square root of 37 plus 6 on top. I may expand that. And then we're going to FOIL this. So root 37 times root 37 is 37. Then the outside would be plus 6 times root 37. Inside is minus 6 times root 37. And then minus 6 times 6. So minus 36. All right, so those two go away. All right, so we have 37 minus 36 on bottom. So I've got 6 on top. I have 16 times the square root of 37 plus 6. And on the bottom, I just have 1. And so I can't, like in this one, we could divide the 6 into the 30. 1 doesn't change anything. So you just end up with 6 times the square root of 37 plus 6. If you want to multiply those two out, you can, but since you can't reduce it any further, then I'm fine with not distributing the 16. All right, 13, we have x over the square root of x minus 2. So times the square root of x plus 2 over the square root of x plus 2. So that's our conjugate. So I'm not going to distribute yet. X times root x plus 2 on top, and on the bottom we will FOIL. So root x times root x, the radical lifts, you just have x minus 2 root x plus 2 root x, those cancel, and then negative 2 times 2 is minus 4. And you can't change that anymore. Remember, you cannot cancel out those x's. Don't do it. It's one of the most common mistakes. The x on bottom is attached to a negative 4. Okay? Whereas the x on top is multiplying. If this were 4x, say on bottom, then we could cross out the x's, but it's x minus 4. X over x minus 4 is not 1. So be careful with that. All right, 14, we have a over the square root of a plus 1. So what's the conjugate? It's the square root of a minus 1. So over the square root of a minus 1. I'm going to resist the temptation to distribute the a because we may not need to. So multiplying the tops, and then we're going to FOIL. Root a times root a is a. Then we would have negative root a, positive root a. Those cancel, and then minus 1. So that a and that a does not cancel, just like the previous one, because it's attached to a minus 1. So I'm not going to bother to distribute the top because it's not going to improve anything. All right, I couldn't quite finish. So we'll get number 15 now. If you are still watching, you are a champion. All right, number 15, we're going to rationalize 4 minus root 7 over 4 plus root 7. Now, this is a good problem because which conjugate do I use? Well, we're trying to get the radical out of the denominator, not the numerator, so we're going to use the conjugate for the denominator, which is 4 minus root 7. But now we're going to have to FOIL both the top and the bottom. So 4 times 4 is 16. And then we've got minus 4 times root 7, which is the outside, and then another minus 4 times root 7, which is the inside term, and then negative root 7 times negative root 7, the radical lifts, so I would have just plus 7. And the two negatives make a positive. On the bottom, 4 times 4 is 16. And then the two middle terms cancel, negative root 7 times 4 and positive root 7 times 4. And then root 7 times negative root 7 would just be minus 7. So on top, 16 plus 7 is 23. And then I've got a negative 4 root 7 and another negative 4 root 7. That's going to be minus 8 root 7. And then on the bottom, 16 minus 7 is 9. 9 will not evenly go into 23 and 8. So I can't really reduce that anymore. What I've seen a lot of students get confused about in the past is this minus 4 root 7 and another minus 4 root 7. They don't know that you can combine those two constants. So there's 8 of those root 7s, and then there was a minus out front, so minus 8 root 7. So that'll do it for this video. I hope you didn't have to watch the whole thing, and I hoped what you did watch helped you out. And I'll talk to you on the next one.